Okay, today we're going to talk about graphing exponential functions. You may want to stop the video and fill in all the red and then come back after you get that filled in. Okay, so you'll notice here this is our standard y equals a. A tells us about stretching, reflecting, and compressing just like it did in quadratics. If a is negative, it's a reflection. If it's greater than 1, it stretches. And if it's between 0 and 1, it compresses. H always comes out opposite, just like before. It tells us our horizontal movement. If it's positive, it moves left. Negative, it moves right. K, if you recall, tells us about our vertical movement. If K is positive, it moves up. If K is negative, it moves down. K is also the location of the horizontal asymptote. If you remember, an asymptote is something that the graph approaches but never touches. It gets really, really close. Okay, so B tells us about the direction of the graph. So B is our growth. If it's greater than 1, it is a growth. If it is between 0 and 1, it is decaying. Now, the graphs can also, if our A is negative, it can have a reflection, so it can grow negatively, and it can also decay negatively. So be careful when it's reflected. A lot of people want to say this is growing, but it is growing, it is decaying negatively. Okay, so let's look at a couple of examples. I just have 2 on here that we're going to look at. You have 4 on yours because I gave you 2 that you could do by yourself, and then you can come back in and check this when I upload the notes. Okay, so here if we put a negative 2 here and this one here, so we're going to use negative 2, 1, 0, 1. I grabbed my graphing calculator and just got some pretty points. So this is going to give me negative 6.7 when I plug negative 2 in here. You can do that in a calculator. And then when we plug negative 1 in, we're going to get negative 5.8. And when we plug 0 in, remember anything to the 0 power is 1. So that would be 1 times 5 minus to that. And that would give me negative 2. When I plug 1 in place of there, that would be 20 minus 7, which will be 13. Okay, so this negative 7 gives me my horizontal asymptote, okay? So that's going to be y equals negative 7, because when you have a horizontal line, that's always y equals. So we're going to go down here to negative 7, and we're going to graph an asymptote here, and this is just a guide to tell me that my graph should get close to that line. Okay, so here we have negative 2, negative 6.7, so that's going to be there, negative 1, 1, 2, 3, 4, 5.8, 0, negative 2, that's our y-intercept, and 1, 13 would be way up there. So notice this graph, if you put it in Desmos, it's going to hold on. If you put it in Desmos, it's going to show it getting really close to that asymptote, but never touching it. And then it's going to go up there. Okay, so that would be our graph. It kind of looks like a backwards J or a C. So our end behaviors as x approaches negative infinity, y is approaching. What's it getting to? It's getting close to that asymptote, so it's going to be negative 7. As x approaches positive infinity, y is going to infinity. So one of these will always be the asymptote here. Our domain, if we ask ourselves what values of x could I put in here? All values of x. So our domain is going to be negative infinity to positive infinity for these graphs. And then our range, we read the range bottom to top. So it starts here at negative 7 and it goes to infinity. Now we know infinity always has a parentheses. Now this one, the negative 7 actually will not be part of the graph. It does not ever touch that, so it's going to be a parenthesis and not a bracket. Okay, growth or decay. If we look at our B, it is a growth. Okay, so that just helps us check our graph off. Okay, let's hop over here to this one here. So this one has 3, 1/4 x minus 5 plus 1. Okay, this x minus 5 tells me that I'm moving my graph to the right 5. So I chose some numbers that were close to the right 5. The plus 1, that tells me my y equals 1 will be my horizontal asymptote. I'm going to go ahead and graph that so I know that the graph has shifted up 1. Okay, and then if I plug 5 in there, 5 minus 5 is 0, and then that would give me 1, and then 3 plus 1 is 4, and then I plug 6 in there, I get 1.75. If I plug 7 in there, I get 1.2. Okay, so if I go over here to positive 5 and I go up 1, 2, 3, 4, this one's decaying, so it's going to start high and go low, 1.75, and then 1.2. So you can see here that the graph's going like that. Okay, again, our end behavior as x goes to negative infinity, what's y doing? It's going to positive infinity. As x is going to positive infinity, y is getting really close to my asymptote, which is 1. My domain is negative infinity to positive infinity, and my range, bottom to top, will be 1 to infinity. Okay? All right. So this here, because this is between 0 and 1, it will be a decay. Okay, so let's look at this here. And we're going to go ahead and look at here at some transformations. So we have, first of all, it's got a negative here, so that is a reflection over the x-axis. And then this 2 tells me it is stretched by 2. The x doesn't have anything with it, so there's no left or right, but the 1 tells me I'm going up 1. My asymptote is y equals 1. My domain is negative infinity to positive infinity. Now, I have y equals 1 here as my graph. I know it's going to be reflected because of the negative, so it's going to be down here. So I can actually do my range from negative infinity to 1. Okay, so I'm going to do some table of values. Since it didn't move left or right, I'm going to use negative 1, 0, and 1. I just looked at my graphing calculator, plugged it in, or you can look at Desmos. When you put negative 1 in, you get 0. When you put 0 in, you get negative 1. When you put 1 in, you get negative 3. From here, I can fill in my Y-intercept. So we know anytime we know the Y-intercept, we know x is 0. When we know our x-intercept, we know y is 0. So I can pull that from my chart. Now I can do a quick little graph. So I have negative 1, 0, 0, negative 1, and 1, 1, 2, negative 3. So this is going to get close to that asymptote, and then it is going to grow negatively. Okay, let's look at some transformations. Okay, same transformations as when we did quadratics. This is our base function. The base function will change based on whether it's growing or decaying. So it could be like y equals 3 to the x, y equals 1/2 to the x. So that number can change based on the growth and decay. So if we look here, this is our base function. So what happened? It's negative here, so it is reflected. It is stretched by 2. My E didn't want to go. And then it is, what does this mean when it comes out opposite? So it's going right 3. Okay, here if we look at this, we know this is compressed by 1/3. And then this x doesn't go left or right, but it's going to go up 8. Excuse me. Okay, so here we're going to take this function and we're going to write it from what's given. So vertically compressed of a factor of 1/3, that would be my A. And then my base is 2. Shift left 3. So remember, left is negative, but it goes in opposite. So plus 3. And then down 8. Okay, so let's do that same thing again. So we know it's 2 to the x. Reflect across the x-axis. That'll be negative. Vertically stretch by 5. So negative 5. And shift up 7. So that's going to be plus 7. Okay, try down here. Notice the base here is 5, so it switched it up a little bit. And then check your notes on plan book.